Items that are packaged for shipping often come with labels or some other means of identification. Typically, labels are placed on such items by human workers, and while this task may seem menial at first glance, workers may be challenged by this task due to a variety of impediments. Some examples include limited dexterity and vision, either from a loss of limb or otherwise, which may cause one to have trouble placing labels into the designated location. To both aid workers with low dexterity or vision and speed up the shipping process, our primary project objective was to create a device that would place a label onto a small box with limited human interaction. Ideally, such a device could be applied to the shipment of packages as well. The device should center the sticker label onto the box, and we decided to make our model scalable to boxes of various widths as well, rather than limiting the application of our device to one size as mentioned in the primary objective. We propose a model that will be able to hook onto a box using two metal L-shaped legs. These legs are adjustable to accommodate for various packaging widths through a large rectangular gearbox located between them, which causes the legs to expand or shrink horizontally. This way, we are able to secure a box in place using the legs while a label is placed in the designated location at the center of the box. The label will be rolled onto the box through a label dispenser that can slide back and forth on these two thin metal strips, and there are pegs at the ends of the strips to prevent the dispenser from falling off the edge of the structure. This model's label dispenser uses a packing slip tape, so to place the packing slip and shipping information onto the box, one need only place the piece of paper in line with the label dispenser and use the handle to smoothly place the tape to cover the paper. To approach the project criteria, we originally came up with a variety of ways to hold in place and label a box. One of our ideas was a label stamper rather than a label roller, and we also thought of using some sort of clasp that would hook onto the corner of a box and hold it in place. However, we believe a label roller with the expanding legs will be easier to implement, and this expanding leg function will be more adjustable to different box sizes rather than a corner clasp. Hence, our final function used these instead. By adjusting the dimensions of the model through use of the expanding legs, we would be able to use the label roller to center a label onto a package with variations in size, thereby fulfilling the primary objective. Our hope is that this model could be used to help those with low vision or hand dexterity more effectively and efficiently label shipments. Some areas for further consideration include adding an attachment for other label applicating mechanisms, such as a small label printer, and streamlining the whole packing process, from the printing of the label to the sending off of boxes. We believe that with some adjustments, our model has the potential to alleviate many complications that come with label packaging.